So this video is going to be some additional stuff for additional functions. So we're kind of reviewing our additional functions unit that we just completed, but we're applying it for new stuff to help get you ready for your final. So we're going to first talk about solving systems of equations using these new additional functions. So there's two ways of doing it. We can solve by graphing, or we can solve algebraically, where we would use substitution. So first let's start algebraically using substitution. So we have x minus 2 squared plus y minus 3 squared equals 9, and y equals negative x plus 8. So just looking at our equations, we know that this one's a circle, and it's centered at 2, 3, with a radius of 3. Alright, y equals negative x plus 8 is linear, and it has a slope of negative 1 and a y-intercept of 8. So just like with our other systems, we're going to take and use substitution by solving for one variable and plugging it into that same variable of the other equation. So here we already have y solved for. So all we have to do is take this negative x plus 8 and plug it in for our y of our circle. Now before we start plugging in, let's think about what our graph looks like. So if we have a circle and a line, right, we can have a line that cuts straight through, and then we have two solutions. We can have a line that touches on the outside, and that's not a line, but that would give us one solution, or we can have a line out in the open, and there's no solution. Okay, so we can have 0, 1, or 2 solutions when we have a circle and a line. So we'll take this y and plug it in. So we end up with x minus 2 squared plus negative x plus 8 minus 3 squared equals 9. So we'll start simplifying, combining our like terms. We have x minus 2 squared plus negative x plus 5 squared equals 9. Now, we have to FOIL this x minus 2 and negative x plus 5. We can't just distribute that 2 because we have a binomial, so we have to FOIL. So x minus 2 squared will become x squared minus 4x plus 4. And then we will add, and then negative x plus 5 will become positive x squared minus 10x plus 25, and that equals 9. Right, now we can combine like terms. We've got an x squared over here and an x squared, which becomes 2x squared. Then we have a negative 4x and a negative 10x, which becomes negative 14x. Then we have our constants of positive 4, positive 25. So we have plus 29 equals 9. Now this is a quadratic because of this x squared, so we have to set it equal to 0. So we'll subtract 9 from both sides and get 2x squared minus 14x plus 20 equals 0. So now we have to figure out how to solve for x. So just looking at this, looking at 2, negative 14, and 20, I know we have a GCF of 2. So first I'll start by taking out a GCF. So then we have 2 times x squared minus 7x plus 10 equals 0. Now two numbers that multiply to a positive 10 but add to a negative 7 are negative 5 and negative 2. So our factored form would be 2 times x minus 5 times x minus 2, and that equals 0. So when we solve, we set it equal to 0, and we get x equals 5, x equals 2. Now remember, when we're solving systems of equations, we're looking for coordinate points. So these are just the x values, and we have to plug them back in and find our y values. So when we plug back in, go for the easiest one. In this case, it's going to be our linear. So we'll say y equals negative 5 plus 8, which is positive 3. So our coordinate would be 5, 3. Alright, then we can plug in y equals negative 2 plus 8, which is positive 6. So then we have a coordinate 2, 6. Now you got to plug back in and check your solutions. So if we plug in 5, 5 minus 2 is 3 squared plus 3 minus 3 is 0 squared equals 9. 0 squared is just 0. 3 squared is 9. 9 equals 9. So we are good. Alright, if we plug this point back into our circle equation, 2 minus 2 is 0 squared plus 6 minus 3 is 3 squared, and it should equal 9. Again, our 0 goes away, so we're left with 9 equals 9. So both of these points are solutions to the system of equations. We can also solve systems by graphing using our graphing calculator. So if you have your graphing calculator, you can get it out. If mine will turn on. So there's several ways of graphing. Right? We just took our test on graphing all of these additional functions, so we can graph it by hand and find our intersections. But we're going to use our calculator, so just so you're comfortable with using your calculator to solve these. Okay, so first we're going to go to our y equals and we're going to plug in our system. So the first one, we're going to have a negative, then in parentheses we'll have x minus 3, close our parentheses, and we're going to square it and add 4. Right, then in our second one, we're going to have an absolute value. So to put an absolute value, first put our a value of 3. Then we're going to go to math, scroll over to number, and our number 1 is ABS. That's absolute value. So ABS, and then we'll put x minus 3 in our parentheses. Then when we look at our graph, we should see a parabola for our quadratic, and then our v for our absolute value. Right, so then when you're looking at your graph, we want to find our intersections. So we can go second trace, go down to 5, intersect. It's going to ask you for your first curve, your second curve, and guess. So we see one intersection is at 2, 3. So we know one solution is 2, 3. Alright, then we can do the same thing. Go second trace, go to number 5 for intersect. And this time when it asks for the first curve, get closer to your other intersection. So your calculator knows you're looking for the other intersection, not the one it just found. Second curve, guess. And we see that our other point is at 4, 3. So we know our solutions to this equation are 2, 3, and 4, 3. Alright, now we have a word problem. A circular pond is modeled by the equation x squared plus y squared equals 225. A bridge over the pond is modeled by a segment of the equation x minus 7y equals 75. What are the coordinates of the point where the bridge meets the edge of the pond? So think about a picture if you need to draw a picture. So we have a circular pond and we have a bridge that cuts across. Right? It just wants to know where our intersections are. Right? We want to know where the bridge meets the edge of the pond. So we're going to have to solve this system. Right? So there's two ways we can do it. We can do it with graphing on a graphing calculator, or we can graph it by hand, or we can plug in and use substitution. So looking at this equation, we know it's going to be linear, and we can easily solve for x. So x is 7y plus 75. Now we can plug this x back into our circle equation to get 7y plus 75 squared plus y squared equals 225. Alright, when we plug this in, we end up with 49y squared plus 1050y plus 5625, and then bring down our y squared and our 225. Alright, we have to combine like terms. We have this y squared and this 49y squared. That gives us 50y squared. And then we can see that this is a quadratic equation. So we're going to have to, again, set everything on the same side. So it's set equal to 0. So we end up with 50y squared plus 1050y plus 5400 equals 0. Now these seem like big numbers, but you can tell that 50 will go into all of them. Okay, so we can pull out a 50 as our GCF. We're left with y squared plus 21y plus 108. We can factor this because 9 times 12 is 108 and 9 plus 12 is 21. So we have 50 times y plus 9 times y plus 12. So y equals negative 9 and y equals negative 12. Now remember, these are our y values, so we have to plug them back in to find our x values. So if we come up here, kind of block it off. Okay, so we have x minus 7y equals 75, or x equals 7y plus 75. So we can say x equals 7 times negative 9 plus 75. 7 times negative 9 is negative 63 plus 75. And negative 63 plus 75 is positive 12. So our coordinate point would be negative 9, 12. Got my parentheses. Alright, then we do it again for negative 12. Alright, 7 times negative 12 is negative 84. Negative 84 plus 75 is positive 9. So our other coordinate point would be negative 12, 9. Alright. The other thing we're going to talk about is graphing inequalities. We've done a lot of inequalities with linear equations. So now we're going to throw in some of our nonlinear additional functions. So we have y is less than or equal to the square root of x plus 5, and y is greater than or equal to 4x squared minus 2. So we're going to do our sketches. So if we come to our crooked graph, right, the square root of x plus 5. Our h value here is negative 5, which means our starting point is negative 5, 0. And we're not stretching or compressing. So we'll go to negative 5. We'll put a point at negative 5, 0. Try to put a point at negative 5, 0. And then our graph is going to go up somewhat like that. Alright, now I use a solid line because of this less than or equal to. If it was just less than, it would be a dotted line. So don't forget your rules. So less than, equal to, greater than, or equal to, we have a solid line. Just less than or greater than, we have our dotted line. Same thing applies even though these are curves instead of lines. Alright, 4x squared minus 2 is a parabola. It's a quadratic function. Okay, this is in standard form as well as vertex form. Looking at it as vertex form, we know that our h is 0. So our vertex would be at 0, negative 2, and this 4 tells us that it is stretched by 4. So we can go to 0, negative 2, put a point. Normally our graph might look something, out here, but ours is going to be a little skinnier because we are stretching it. Okay, so now we have an idea of what our graphs look like. We got to think about where we're going to shade. Okay, so when in doubt, you can just plug in a point. The easiest point to plug in is 0, 0. So if we plug in 0, 0 to y is less than or equal to the square root of x plus 5, we end up with 0 is less than or equal to the square root of 5, which is in fact true. Okay, so because 0, 0 is true for that first one, we're going to shade on the side that has 0, 0. So we're going to shade down here. Alright, now remember, because this is a square root function, we have no x values to the left of this negative 5. So our shading goes straight down and to the right. We don't have anything past that because we have no values there. Okay, y is greater than or equal to 4x squared minus 2. If we plug in 0, we end up with 0 is greater than or equal to 0 minus 2. So 0 is greater than or equal to negative 2, which again is true. So we're going to shade on the area that has a 0, 0, which is inside our parabola. Alright, so our solution region ends up being in here, including our lines because they're solid. Super quick, the last thing I want to show you is how to graph inequalities on your calculator. So go to your y equals and type in each of these equations as your y1 and your y2. Alright, then once you type them in, to the left, on the left side of your y1, you have a straight line. If you keep pressing enter, you can choose your inequality. So get it to where you have the top right part shaded, and that means it's greater than. If the bottom left is shaded, that means it's less than. So your calculator won't do a solid or dotted line, but it will graph it and show you where it should be shaded. Really cool trick.